Hello everyone. Let's wait for a few more seconds for other participants to join. Let's give them 30 seconds more. Okay, let's assume that all the participants are online. So hello, I'm Bogdan, and I want to talk with you today about the agility with Springboot. So as I said, I'm Bogdan Flore. I'm senior Java developer within around 14 years of experience. I'm passionate about real-time databases and public transportation. I already have a mobile application which is running in 4 cities in Romania, used by thousands of citizens to see the public transportation vehicles in real time on a map. I'm working in Yonder for around 8 years, mostly for the same client. A client which have a software solution used in healthcare domain. And I guess now we have also the polls results. So it seems that in the audience we have 71% of the people who is actually working currently on a monolith application. And let's see at the end of the webinar if they have the same feeling about their application. So today in this webinar, I will be talking about how me and my team successfully conducted a migration of a legacy application from WebLogic to Springboot. I will discuss about how we took the decision, what were the benefits of doing this migration, and share with you some tips and best practices. We have transformed a system which used multiple different inconsistent application server into a simple solution based on independent modules built on a basis of Spring Boot, SpringCloud, and Java 8. So first of all, let's share with you how the initial system looked like. So back in 2019, as I said, our client had a software solution for a healthcare domain. And first part of the solution was a web application used by patients to interact with their doctors. This was this was implemented with Groovy for backend, with Gorm as ORM, Grails for frontend, and was running with Java 6 under WebLogic server. We also had the second part of the application, which was a bunch of web services, a lot of web services, REST and so. So this web services was used by our applications to interact with the database and interact with other systems. Before the migration, all of these APIs was very, very tight together, each other, running under the same WebLogic. So sharing the same properties and resources. And the third part of the, as I said, these two applications was running on WebLogic. And the third part of the our system was a mobile application, which was built with the Ionic frame and consume some REST APIs. This web application does, this mobile application does mostly the same thing with the web application, but in additional, it has some functionalities like push notifications in the case that you as a patient have a doctor appointment, or it sends you a push notification when you have to take your medicine, and so on. And we, at that moment, we stay and analyze what are our issue with this huge system. And we came to the conclusion that it's very, very hard for us to bring new functionalities in production. A second issue was that we identified a lot of modules, which was part of this monolith, that needs to have faster releases. So I think that the first sign that your application is giving you that maybe it's too fat for a microservice is that you identify modules we need faster deployments in production, faster development for that specific module. Development environment was really hard for us to start all of those components and WebLogic on our machines. We had a lot of legacy code and old libraries. And we had a lot of vulnerabilities. So dependency which was identified to be vulnerable with for a lot of risk. Also, something that was important for us, we need to shut down the entire system to do the installation in production. So we wanted to find a solution not to have this issue anymore. And the list, this is a good thing, but actually help us to understand that we need to do something. The legislation was changed in that country where the client had the software for, and we had to expose our medical data to external application, of course, in a securely manner. And with the infrastructure that we had at that moment was really risky for us. So what we did is to stay together with the architects and all the people who was involved in this project and define what we want to achieve with our system. And we say, okay, we really need to build a test for our backend. And not only the test itself, we want to have 85% of our code coverage, but we also wanted to include PI tests, so mutation test, which is a tool that you can enable it in your pipeline to check if your tests are really doing the right thing. So it gives you a level of how much trust you should have in your test. So don't forget about PI test. We said that we want to have the opportunity to add a front-end test. We also wanted at the end, our system, we want to have integration test, and we add them with Karate, so API testing. And we said we really want to have zero vulnerabilities. And for that, we used OWASP. And we said we need to have independent lifecycle of components. So we don't want to wait for releasing one specific module just because another module was not done in time, you know. And we want to have this life cycle, independent life cycle. And we want to have a console where we can monitor and interact with our application. So we came up with this this architecture, and I stayed this morning and I was looking on the participant background, and I say, how can I explain this architecture for non-technical people? And I will came with an example. So I think all of us are working on an application which brings values for people. Healthcare domain applications, public transportation application, government application, insurance applications. So I think I legitimately can compare that our software is like our president of the country. And to make it more specifically, just imagine that your software is the president of the United States. What is the first thing that the president of the United States does when it is deployed, so when it is selected by the people? So he came to the TV and said to all the people, guys, starting with today, my door is open for you and I will solve you whatever issue you have. Which door? Of course, the door of White House, you know. So next day, first user came to the president, knocking on the door, and the president is there. Okay, my people, what is going on? Of course, the president is not there alone. He's with Chuck Norris and Gerald Butler and a lot of soldiers being there to defend him against of possible risks. But dude, what is going on? So the user gave him the list with the issues, and the president will try to solve it. Okay, but this is a financial issue. Came with me, and I will guide you in the White House, on the office, which can solve you a financial issue. And this is also happening with our software. We build a software, we put it public, we give the users the opportunity to see behind of our interface. So this is the software, and this is what we see. What I notice in a lot of applications, that you can see what frameworks the development team used. You can see what language is used. You can also deduce what APIs are, and this should not happen. Just imagine that someone else could think to a different approach and say the president of the United States doesn't have to stay on the White House. White House should be something hidden for the people. Just imagine that if someone said, what will be if the president will stay in a forest or in a cloud? Now maybe you can get it now. So what will be if the president stay in a cloud and will have an interface, which is the White House, and that interface only listen to an email address or something that is not physical. So no one can know where the president is. So the risk of having security alerts is less. And in that way, we should not spend a lot of money in securing something that no one can reach it. And this is API Gateway. So API Gateway is an interface that you should provide to your users. But what is behind the API Gateway, you should never provide. And this is enough. So we still have a web application, we still have a mobile application, and we have third-party application which make requests on our backend, but they only see this API Gateway. And in this API Gateway, you can add different roles, like this API Gateway can check the security. Does this user have rights to send a letter to the president? No, because he didn't vote it. Just joking. No, you can say, okay, but does the user have a JVTW token? So you can add security on this layer. You can monitor. You can say how many financial requests came to the president in the last week or month or whatever. And because all the requests came to this API Gateway, you can monitor all. You can have reports about all the stuff that you are interested in. You can add load balancer. So in case that a lot of requests came for financial issues, you can say, okay, but maybe it's time to hire new financial consultants and so on. So you can have the load balancer like this and routing. And of course, in this architecture, you can see the service discovery. So service discovery is a microservice which has the role to listen for other microservices. How this works? So service discovery, when you started, is stay and we listen in your cloud, and when for example, when web service 1 is starting, it says to the service discovery, hello service discovery, I'm web service 1 and I'm listening to this URL and to this port. And the same for all of this. And when a request came to API Gateway can say, register discovery, I have this request for a financial issue. What is the service which is responsible to fix my problem or to resolve my request? And service discovery can route your request to web service 1 or whatever. And the same, web service 1, if he needs to do a call to web service 4, he doesn't have to know the location of web service 4. He just requested to service discovery to route the request to the web service 4, and so on. And we also wanted at that moment to have cloud configuration. What that means is that in the cloud infrastructure, you should not embed your configuration in your application. The configuration should be flexible enough to cope with multiple applications, environment, and service instances, as well as dealing with dynamic changes. So actually at runtime, you can change one configuration for your application and without being the need to restart your application. As I also mentioned, we need a health dashboard. So we wanted to have a console where we can monitor and interact with our application. So we can easily see the memory that is occupied by our applications and so on. But the most important thing is to be able to change configurations at runtime. And just imagine that you can change the log level. So if someone calls you that it has an issue with a specific functionality, you can increase or decrease the log level and tell the guy to try it again. And you can see the logs in your log files. And you can do that only for 1 minute because it's production. You cannot afford to have a lot of logs like. We also want to have traceability. So debugging distributed applications can be a complex task. For any given failure, you might need to piece together logs from several independent services. So SpringCloud offers a library, which names is Sleuth, which assigns a trace ID for each request. So when the request came to API gateway, it assigns a trace ID, and that trace ID is propagated through all the requests that you have to do in your chain. So from API gateway, you pass a trace ID to web portal. From there, you pass the same trace ID to web service one, and you just have to be sure that you log that trace ID in your log system. And after that, with a tool like, I don't know, Splunk, you can collect all the logs from all the log files, and you can query, and you can see where, in which component the failure came from. And we wanted to avoid the downtimes, and with that you can use Zul proxy. And my advice for you is to deploy each component at least on 2 different machines. So if you do that with a Zul proxy, when you have to bring a new functionality and you need to install the version 2 of Web Service 1, you can just configure the Zul proxy to say, okay, for the next 10 minutes, route all the messages, also all the requests to the machine 1, and in the meantime, you can install the second version to the machine 2. And after that, change back the configuration and say, now I install it on the machine 2, Zul proxy, please route all the messages to the machine 2 and do the installation on machine 1. And in this way, you can have no downtimes between the installations, and you can, of course, deploy each component by itself. So mainly, this is the infrastructure, the cloud infrastructure of Spring Boot and SpringCloud. Of course, different application can have multiple levels or layers and so on, but this is what we built. In the end, this picture summarizes how the application, the system looks like now. So we still have Grails because we moved part of the Groovy code in Java, but we didn't manage to do it completely. So we still have Grails and Gorm, but in the same time, we changed the UI from Grails to React. And as I said, we added front-end test with Nightwatch. And part of the code, as I said, was moved to Java microservices. For mobile application, we started a migration from Ionic Free to React Native, and we added a run-OS test for it. And as I said, we had to build new APIs to expose to for external applications. So we had third parties integration. And as I said, our Java code is based on Spring Boot and SpringCloud. We introduced continuous integration, continuous delivery with Jenkins, Sonar, and all the stuff. We end up with around 25 microservices, each of them with their independent lifecycle. And we communicate with REST API. And for all the backend, as I said, we had the goal to reach 85% of the code coverage. We use JUnit 5. And all the components has the latest version of Spring Boot and SpringCloud. We just upgraded 1 week ago. And now let's share with you how we took the decision. And the main aspect of Springboot that determined our decision was its flexibility. We faced the following challenge. We were given code that dates back to even 2009. And at the same time, we had the completely new modules that we had to create by ourselves. So how can we run all of this together? So we came to the conclusion that Springboot is flexible enough to let us replace the default components and hide the whole level of complexity of the legacy applications under a certain layer of abstractization. Another aspect that helped us in taking the decision was the number of available starters that we have in Springboot. So with few clicks, you can have one specific type of project structure with all the dependency. You just have to put your code there. Another aspect was the fact that we wanted to avoid the application server. And one of the reasons was that for us became a sort of mutual and unclear responsibility between operations and development team. We didn't know exactly who should maintain the application servers. And if no one wants to maintain it, why don't we get rid of it, you know? I also remember that we had a lot of custom WebLogic library, and migrating to a new version of WebLogic or to a different application server will mean to maintain those libraries. And finally, the obvious reason, license cost. So with Springboot, you can choose between Jetty, Tomcat, and Undertow, which is a free server, versus WebLogic cost, which is not trivial. And let's see some benefits. So first of all, the migration opened a world of possibilities. It simplified our entire infrastructure and accelerated the deployment in production from several hours to minutes. It accelerated our development. It accelerated our deployment in production, I said, but it also accelerated the development environment. We can easily start the components that we need, and it makes our lives as a developer much, much easier. Also, Springboot enables us to create independent, self-sufficient microservices. They can be deployed as a single executable jar file. It eliminates the need to maintain application server as a runtime environment. The web server is an integral part, so you can choose between Jetty, Tomcat, and Undertow. The server, the type of the server that you want to choose is configurable in like a normal dependency in your Gradle file. So thanks to these functionalities, Springboot allows us to focus on application itself rather than everything else around it. And of course, the benefit of having a free server instead of a paid one. Now I want to share with you some tips and best practices. And first of all, the migration was not a one-to-one migration that you will say, let's remove some code from server and launch it on Springboot. So this is the fundamental challenge when you are working for a running software. We cannot say to our clients, listen, we are stopping the world, halting the development, and doing the migration. We often work on a critical application, and we cannot afford stagnation in development. So if a certain functionality is needed, it must be introduced. Another advice is to go step by step. So make sure that a given module is migrated as a whole and avoid conducting other operation during this stage. If we are migrating a given fragment, we always make sure that everything runs properly, and only then we proceed to the next step. Again, do a test. So creating automating tests is the priority for a migration. So developing automated tests should be a priority. Do not start a migration if you don't have a tool which can give you a certain level of confidence that you haven't broke anything. Migration is a priority. So during the migration, when we're examining the code or the modules, we might be tempted to introduce some changes or improvement. Let's avoid do that. We should do minimum work necessary for migration. Another tips is to take into account the risk. So always remember about the risks. When conducting the migration, we not only should, but we must introduce separate infrastructure releases from functional releases. Hence, when delivering infrastructure migration, we should not introduce any functional changes. When adding functional changes in a given version, we should not tackle infrastructure. So pay attention on that. Because we are talking about risk, let's talk about rollback. So be prepared to always have a good rollback plan. It may turn out that, especially in a system with a lot of components, that one of the components refuse to cooperate, even if everything looks okay at the beginning. For example, we introduce we use Liquibase to track the database changes between one version and another, or we always do database backups before each installation. Okay, also you should realize that migrating the first module will take a bit more time than the rest. We must deal with a certain learning curve. We learn new technologies, we discover the entire infrastructure and so on. However, completing the initial stage will pay off quickly, and the migration of other modules became much faster. This is a nice one. So managing this huge number of components might become overwhelming for a development team. So DevOps team should came with an easier and automated solution. So don't start a migration if you don't have a competent DevOps team. Don't forget to cherish your success. So when we introduce a new functionality that is visible on the screen, the user will say, yes, yes, I'm happy with that. This makes our life easier, and so on. Unfortunately, in case of an infrastructure change, no one pays attention on that. And the development team should find a way to show to the world that they moved forward. And it's very important for their morale. And the last advice, don't do the migration by yourself. So you don't have to put all the energy and all the developers to do this migration. In our case, we split the migration between 3 teams from 3 different countries. If you have the good KPIs, if you have the goals set from the beginning, you can split the migration between different teams, and all of them can work separately for different modules. So build different microservices by themselves. Thank you. This was my presentation. Now I will try to answer to some questions if they are, and I will. If you want to keep in touch, you can reach me on this email address. And now I will start with questions. So let's see the question. Okay, first question from Ralph. When you create a Spring Boot service in a Docker container and deploy it in a Kubernetes environment, is the use of Zul then necessary? To be honest, we don't use Docker container, and we don't deploy them on a Kubernetes environment. So I don't know, but we use Zool as a proxy implementation, but you can use whatever proxy is suitable with the environment. So if Zool is not an option for Kubernetes, you can, for sure, they have a different solution. I just gave an example, Zool, because this is what we used. But I cannot answer if that one is available for Kubernetes, because I don't know. Okay, I hope it's answer to your question, but as I said, you have to Google it to see if it is suitable. Another question is, why did you use API Gateway? So as I said, having a layer which is like a contract between your web applications, so between your clients and your backend, and that layer is responsible to hide everything which it is responsible to hide the implementation, so to minimize the risk of attacks in such a way. And if you have an API gateway, you can independently build your backend as you want. If you, in the near future, you will consider that the web service one needs to be split in 2 other microservices, you can split it, you can change it without having the need to inform your client, because your client is communicated with you only with that API gateway. As long as you don't change the API gateway, so the JSON that is transformed between front-end and back-end and vice versa, you should not care about it. So you can build your application as you want. You can build your services as you want. A question from Antoinette. Why do you say a DevOps team is necessary? As I said, we came up with around 25 components, but depend on the applications, you might have even more than that. And maybe for a few of them is easier, but after you have such a amount of components that you have to manage, you need to find a way to automate your builds, to automate your deployments, to automate your I don't know, analyzing the vulnerabilities, or analyzing your code. You need to find a way to automate all of this, because as I said, 25 is not the highest number of components in one system that I heard. I also heard systems with hundreds of components, and of course you can ask the development team to Google it and, I don't know, learn how to automate stuff. But I am pretty sure that a development team cannot reach the same knowledge as a DevOps team. A question from George: do applications create with Springboot integrate with the 365? To be honest, I don't know. Normally, when you create a Spring Boot application, you obtain a jar, which is an executable jar, and you can run it on each of the system, even Java, Windows, Linux, or whatever. I don't know what the 365 means, but normally you should be able to start it as a regular executable jar file, and embedded in that jar file you have a Tomcat or whatever server you want, and that server is running your application. So I really don't know.
You have a question on the chat that goes, isn't the gateway a new bottleneck and single point of failure?
Yes. So indeed, API gateway is a single point of failure, but API gateway, you should see it like a microservice, and you can deploy it multiple times as well, and you can have a Zool proxy in front of it as well. So you don't have to have only one instance of API gateway. And in the same time, you can divide your API gateway between your type of application. In our case, for example, we have an API gateway for a web application, which reach our backend, and you can also have an API gateway for mobile applications, which can be slightly different. So, of course, you have this a single point of failure, and of course, it adds complexity because your request it has to cross this API gateway. But in the end, the roles that you can add in this API gateway, in my opinion, will add a lot of benefits for your system. So yes, indeed, it is a single point of failure, but in my opinion, if you deploy it on multiple machines, you should not take care of it. Let's wait if we. Yeah, and another question was how can we ensure that the Spring Boot doesn't bring a lot of vulnerable dependencies? And as I said, we use a tool, OWASP, which analyzes all the dependencies that we have in our components, and we often, so we regularly each sprint we monitor the result, so the report of OWASP build. I don't see any other question. Now maybe it's good to share the result of the end poll, and the result says that 83% of audience is still thinking that they are working on a monolith application. So my advice is to go to your product owners, go to your clients, go to your architects, bring them the good reason to do the migration, and let's hope you can convince them to invest energy, time, and money on doing this migration, because in the end, you will only have benefit. So, as we don't have any new question, I think this is all for today. Thank you for attending, and we can connect each other on the email address that I show it to. I show it here, so we can link together and discuss further on if you need. Thank you. Goodbye.